In this video, I'll explain how to convert ASCII to packed BCD format, and then I'll show how to write assembly language program in 8085 for this conversion. As we all know, the BCD numbers 0 to 9, they are represented by ASCII values from 30 to 39. That is, BCD equivalent of BCD of 0 is equivalent to ASCII 30, 1 to 31, and so on 9 to 39. Now, here I'll show how to convert ASCII to packed BCD format. That is not from digit to digit. So, a 2-digit BCD number. So, let us consider 35 and 38 ASCII values, and we will try to convert them to packed BCD format. How to convert these values to packed BCD? For this, as we all know, ASCII 35, its equivalent in BCD is 5 because 0, BCD 0 is equivalent to 35, 30, 1 to 31, 2 to 32, so on, 5 to 38, 5, and so on, 8 to 38, and 9 to 39. So, the BCD equivalent of 35 is 05. So, for this ASCII 38, its BCD equivalent is 08. Now, we want it to be converted to a packed BCD format, that is a 2-digit number, that is 58. Now, let us see how to convert from this ASCII values to the BCD number 58. So, if we take the first step, so we are giving 35 and 38 ASCII values. Now, we need to separate the least significant bit from 35 and 38. This can be done by using AND operation, because if you see the AND truth table, 0 and 0 is 0, and 0 and 1 is 0, 1 and 0 is 0, 1 and 1 is 1. See, if we perform AND operation with the 1, whatever be the number, right, we'll get that number. So, we'll first convert 35 to 05 by using AND operation, and we'll AND with 0F. So, convert first the numbers to binary. So, binary equivalent of 3 is 0, 0, 1, 1, 5 is 0, 1, 0, 1. And 0F, 0, 0, 0, and F is 1, 1, 1. Now, perform AND operation. 1 and 1, 0 and 1, 1 and 1, 0 and 1, 0. And if you perform AND operation with 0, we get only zeros. So, what is this number? This is 0. This is 5. So, for 35, if you perform AND operation, 35 ASCII value, we perform AND operation with the 0F, we get 0, 5. Similarly, if you take 38 ASCII, again perform AND operation with 0F, then we'll get a 08. And the next thing, what we have to do is we have to convert into packed BCD. So we have to convert this BCD to move the LSB to MSB position. That is, we have to make it as 50 and add with the 08. So that we'll get 58 as a BCD number, but the ASCII equivalent of 35 and 38. So the first step is, first we have to get the equivalent of 35, that is 05 BCD, 38, 08. And then after that, we have to rotate left the binary equivalent of this number to get 50. So 0, 5, we must make it as 50 and add 0, 8 to get the BCD number 58. Now let us see what happens if we shift 0, 5 4 times to the left. So 0, 0, 0, binary equivalent, 0, 1, 0, 1. So first rotate left. So we'll get 1 here and all shifts their position to left by 1 bit. So after first rotation, we get 1, 0, 0, 0, 0, 0, 1, right? This will be moving to 0 here and here. After second rotation, so this comes to here, and again, all the bits will go left by 1 bit. So now the number will be 0, 1, 0, 0, 0, 0, 0, 1. Next, after third rotation, this one comes here and so on. So it comes 1, 1. So 1 will be coming to here, 0 will be moving to here, 1 to here, 0, 0, 0, 0, 0. Now, after the fourth rotation, this comes to here, so 0. This will be moving to the left. So 1, 0, 1, 0, 0, 0. This is nothing but 5. This is so 0, 5. After 4 rotations by left by 1 bit, we get 50. Then add 0, 8. Then we'll get the packed BCD number 50 again. So what are the steps that are involved in the conversion of ASCII to packed BCD format? So when we say packed BCD, we are it is a 2-digit number, right? So for that, take two numbers 35, ASCII numbers 35 and 38, and to get their equivalent, we already know that 35 is ASCII value of 0, 5 and 38 is 0, 8. To get this, we have to separate 5 from 35. That can be done by using AND operation of 35 with the 0F. So we'll get a 0, 5. Similarly, 38 perform AND operation of 38 with the 0F to get 0, 8. Now to get 2-digit packed BCD format, consider 0, 5, rotate left with carry by 1 bit. So it becomes 4 times if we rotate, we get as 50. Then in the last step, we add 0, 8 to this number. So we'll get 58. So ASCII BCD, packed BCD of ASCII 35 and 38 is 58. So let us write the assembly language program. So first we'll store the first number 8500 in 35 ASCII number, 8501 location 38. Now, so get LXI H comma 8500. Now 8500 contains your first number ASCII value 35. Then move that to the accumulator. Now accumulator contains your 35. And immediately the contents of accumulator, which is 0F. So and operation is performed 35 with the 0F and 0, 5. The result will be stored in the accumulator. Now rotate this left by 4 times so that we'll get 50. So RLC, 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 RLC. After 4 rotations, the accumulator will contain the number 50. Now get the second number that is in the memory location 8501, that is 38. Increment H. So now it is pointing to 8501. Move A comma M. Get the contents of 8501 to accumulator. Now accumulator contains 38. Now before incrementing this, we have to move the the result that is 50 in the accumulator to B, you can move it to B, move B comma A. Now B contains the 50. Now increment H, now get 38 to accumulator. Now what we have to do, perform AND immediately the contents of accumulator with 0F. So AND with the 0F, and after adding the result that is 08 will be in the accumulator. Now accumulator contains 08 and B contains 50. What you have to perform now? Add B adds the content of B with accumulator. So 08 plus 50. So 58 will be in the accumulator. Store that result in 8502. Now 8502 contains the packed BCD of ASCII values 35 and 38, that is 58. Now we'll write the output. So LXI 210085, move A comma M 7E, ANI 0F E6 0F, move B comma, rotate left, that is 07, you all know, 07, 07, 07, 07. Move B comma A, 47. Increment H, 23. Move A comma M, 7E. Again, ANI 0F, that is E6, 0F. Add B, 80, and STA 32, 02. So I once again repeat how to convert ASCII to packed BCD format. So we all know the packed BCD numbers 0 to 7, 0 to 9, sorry. The ASCII equivalent of 0 to 9 is 32, 30. Right? Look, to convert to packed BCD, that is 2-digit BCD number. So consider two ASCII values 35 and 38. 35 and 38. Separate 5. So this we can perform the subtraction with 30, 35 minus 30, or we can perform AND operation. And 35 with the 0F and 38 with 0F, and separate the least significant bits so that we get 05 and 08. After that, shift the first number to rotate the number to the left by 4 bits, so that it will be converted to 50, and take the second number as it is, add both, we get the equivalent BCD number, that is 58. I hope you all understood the procedure to convert ASCII to packed BCD format. Now was a video for execution.